Today we're going to look at absolute value inequalities. And this combines the two last topics we've looked at. So absolute value equations and inequalities for ands and ors or compounds doesn't make a difference. Okay, so let's see how this works. So we're given an absolute value, but this time it's got an inequality versus an equation. All right. Now, one of the tricky parts about this is that unlike the inequalities we started with, which are and or, and it says it, or they're compounds, and all compounds are ands, this one doesn't have anything. Okay, so how do we figure this out? We look at the inequality sign. All right, our inequality here is a greater than or equal to. Well, it's a great or. So anything that's greater is going to be an or problem. Okay, so it could be greater than or equal to or just greater than, but it's an or. All right. So just like with absolute value equations and inequalities, we're going to make two separate inequalities. All right, and when you make the first one, you're going to drop the absolute value signs just like you would in an equation, and the second one you switch the sign just like you would in an equation, but this time we flip the sign. Okay, so now a greater than or equal to becomes a less than or equal to. All right, and why do we do this? Because to change the 5 to become negative, we multiply or divide it by a negative number, so then the sign flips. Okay, remembering that this is an or problem, we now take our equations, our inequalities. We solve both of them by adding 3. So the first one, you're going to x is greater than or equal to 8. The second one, you're going to get x is less than or equal to negative 2. Okay, so now we just do this like normal, like we've done for the inequalities in the past. We start at 8 with a bracket going to the right, and negative 2 with a bracket going to the left. All right, and finally for this problem, we put our interval notation. So it's starting at negative infinity all the way to the left, going to negative 2 with a bracket, or a sign to connect them with a 8 with a bracket going towards positive infinity. Okay, again, just like with inequalities when we started, I'm looking for 3 things. 1, did you solve the inequalities correctly? 2, did you graph it correctly? And 3, do you have the correct interval notation? Okay, let's check out another one. So we have the absolute value of negative x plus 3 is less than 2. So this is a less than. So anything that's less than or equal to is going to be an and question. All right. Just like before, we solve these inequalities by splitting them up, making one inequality with the answer that you're given, and then changing the sign on the other one. All right. This is an and, just to remind you. All right. Again, make sure that you flip your inequality in the second equation. You solve these both by subtracting 3 and dividing by negative 1. So that'll flip the sign for the inequality. So it now reads x is greater than 1 and x is less than 5. All right. For our graphs, we start at 1 with a parentheses going to the right, and then 5 with a parentheses going to the left, and overlaps between them. All right. Our interval notation will be 1, 5. Parentheses. All right. Again, we're looking for the correct inequality answers, the correct graph, and the correct interval notation. So we've done 2. Try this one on your own. Pause the video, come up with the answers, graph it, and write down the interval notation. All right, hopefully you've paused it, and now you're back. You've answered it, and see how you did. So this one is a greater than, so it's a greater. All right. We make our 2 inequalities. We have 3x plus 3 is greater than 3. 3x plus 3 is less than negative 3. All right. Again, make sure you remember it's an or. So we have the first one is x is greater than 0. Second one is x is less than negative 2. Put a parentheses on 0 going to the right, parentheses on negative 2 going to the left, and write your interval notation. So hopefully you've gotten this all right. If not, make sure that you go to a Zoom session and ask some questions. All right. Let's try a little bit different kind of problem. It's the same idea, but there's a little bit of a wrinkle to it. All right, and the wrinkle is, in order to solve these, we have to get the absolute value brackets isolated by themselves. And right now, that's not isolated because you have that minus 6 on the end of it. So we're going to add 6 to the other side and get us this. Okay, now that we've isolated the absolute value, which is what we've done, It's all by itself. There's nothing being multiplied or divided or added or subtracted to the absolute value brackets. Right? And now we can start doing the previous stuff we did, which is figure out whether it's an and an or, and then also solving the inequalities. Okay, in this case, because it's a less than, it's an and question. We have our two inequalities, one with a positive answer, one with a negative. Again, making sure that we flip the sign on the inequality in the second inequality. Okay. In both cases, we're going to subtract by 2 and then divide by 3. So in the first one, we're going to get x is less than or equal to negative 1/3. In the second one, x is greater than or equal to negative 1. Right. Again, kind of a refresher of graphing. I don't need all the different numbers on a number line. I just need the ones we're doing. Okay. So you have negative 1/3 going with a bracket to the left, and then negative 1 with a bracket to the right. And it is an and, so we're graphing where they overlap. All right. And then the interval notation is going to be negative 1 to negative 1/3 with brackets. Okay. So again, another version of this. Okay, now we have something being multiplied by the absolute value brackets. So what we're going to do is we're going to divide by 6 on both sides. When you do that, you'll get this. X, absolute value of x plus 1 is greater than or equal to 3. So because it's a greater, it's an or. Notice we have isolated the absolute value bracket, so now we can make our two separate inequalities, one with a positive answer and one with a negative answer. Okay, so we solve these by subtracting 1. We'll get x is greater than or equal to 2. X is less than or equal to negative 4. So we put a bracket on 2 going to the right, a bracket on negative 4 going to the left, and write our interval notations. All right, so we've seen two of this type where you have to isolate the absolute value. So try this one. So pause the video for a second, try this problem, come up with your answer, graph it, write down your interval notation, and then come back to the video. So hopefully you have paused it, solved it, graphed it, interval notation, and now you can just check to see if you got it right. So we're going to subtract by 3 on both sides. Now that we've isolated the absolute value, we can make our two inequalities. We can also figure out what type of what type of graph it's going to be. It is a less than. It's an and graph, where it must overlap. Our first inequality is x plus 4 is less than negative 1. Then we have x plus 4 is greater than 1. So we solve these both by subtracting 4. We end up with x is less than negative 5, and x is greater than negative 3. To graph this, we're going to have a parentheses at negative 5 going to the left, and a parentheses at negative 3 going to the right. Now this should raise some red flags because in this case, it's an and question, but the graphs don't overlap. And that means it is a no solution. Okay, there is no number that will make this inequality true because the absolute value causes issues. Okay, so think about it in this terms. No matter what comes out of the absolute value brackets with x plus 4, it's always going to be positive, and a positive number is never going to be less than negative 1. So there cannot be a solution for this particular inequality. Okay, well, go try the practice and good luck.